Welcome back to Hacking Math. Let's look at an algebra problem that a user on Reddit posted for help. It looks like a parabola and a line, and you have to find out where they intersect. And then all the numbers have to be between -9 and +9, just not 0. So we'll draw this, and there's the parabola, for example, and then a line goes through it. And all of the answers have to be between -9 and +9 in the x direction and the y direction. We don't have to worry about anything outside of those limits. So how hard could it be? Maybe we should just plug in some numbers. So the parabola has the formula y is equal to ax squared plus b. A and b are two integers. Same way with the line. Y is equal to cx plus d, different integers between -9 and 9. So we could just plug in some numbers at random, not random, but is it 1, 2, 3, 4? Which would mean we've got y is equal to 1x squared plus 2, and the line would be 3x plus 4. How can we find out whether that's the answer? Well, where do they intersect? Let's set them equal to each other to find out what x's work for those two equations. Bring the 3x over, bring the 4 over. Then we're left with a quadratic equation, which we can solve using the quadratic formula. You know, x equals -b plus or minus radical, that one. Well, here b is -3. B squared is 9. Minus 4 times a times c. So that's 9 plus 8. And the whole thing is divided by 2a, or 2. So we simplify, and under the radical, you've got 9 plus 8. The two negatives become a positive. So the square root of 9 plus 8 is the square root of 17. And that's not going to be an integer. So that's going to mess up our answer. Neither of the x's is going to be an integer, and so that doesn't work. So we have to try again. Maybe it's 2, 3, 4, and 5. Maybe a is 2, b is 3, c is 4, d is 5, and so on. So we have to do it all over again. So y is equal to 2x squared plus 3. And for the line, y is equal to 4x plus 5. We set those two equations equal to each other. Bring the 4x over to the other side. Bring the 5 over to the other side. That'll be what? -2 equals 0. Another quadratic equation. We can simplify it. And then we plug it into the quadratic formula again. But we know that b squared minus 4ac has to be a perfect square. If you take the square root of that, it has to be an integer. Well, that's going to be 4 plus 4, or 8. The square root of 8 is not an integer. So those four numbers don't work for a, b, and c, and d. So we got to try again. Or we could use another tool. We could get the computer to plug in those numbers for us and then solve for x. Plug it into the quadratic formula, right? So let's see, just like before, we're doing x1 and y1, or the one of the intersections, x2, y2, the other intersection. And we've still got the quadratic, y is equal to ax squared plus b. And the line, y is equal to cx plus d. So if both of those are equal to y, then they must be equal to each other. So ax squared plus b must equal cx plus d. Just like before, with real numbers, we bring the cx over to the other side, we bring the d over to the other side. You're left with ax squared minus cx plus b minus d is equal to 0. quadratic equation. And we can plug that into the quadratic formula. A is A in this case, B is negative C, and C is B minus D. So x equals negative B. Well, B is negative C, so negative B is C. B squared minus 4AC. Probably getting mixed up with all the switching the letters around, but that's the way that's the solution to that quadratic formula. Now we can put that into Python. We'll need to import a couple of packages, and we need our parabola function that will return ax squared plus b, and a line function which will give us cx plus d. Then finally we can do the quadratic formula. So that we'll put in the values that we get from the parabola and the line, and get our x values for the intersections. Of course, if it's a negative, the discriminant's a negative number, we're not dealing with complex numbers here. So there's our negative b plus or minus radical, etc., etc. Now we got to generate the numbers. So the numbers are going to be all the numbers from negative 9 to 9. Now the solve function. This is where we're going to get all the permutations of our number range taken 4 at a time, and it'll put it into A, B, C, and D. And then we'll keep going with our computations. And if anything doesn't work out like we did before, we're going to put continue. Go back to the beginning of that loop. So if the discriminant is negative, yep, continue. Those numbers don't work, get 4 more numbers. You're going to see that a lot. Take the square root of the discriminant. Now if that's not an integer, you're going to continue, meaning go back to the beginning of the loop. Get 4 more numbers. But if you can keep going, then check if the quadratic formula gives us none. If it does, then continue. Those aren't the right numbers. Otherwise, you're going to get 2 numbers, x1 and x2, the 2 x values that are the solutions to that quadratic. Check if they're integers. But if they're not, 3 guesses? Continue. If they're not integers, you continue, get 4 more numbers. But if you can keep going, then set those numbers, the x values, to integers, and then find the y values that correspond to those. I just plugged them into the line. I should have used the line function. Now, if they're not integers, continue. They're not the right numbers, so we get 4 more numbers and keep doing this until we get some that work. Otherwise, let's set those to their integer values, just so you don't have a 0.0 on it. We have to check. Here's the line where we check if any of those numbers are already, if they're not in nums, if they're outside the range. Otherwise, our solution is that list of those 8 numbers. If there are any repetitions, the solution set will have a different length than the solution list. So can't have that. Otherwise, that is one of our solutions. So increase the number of solutions that we got, and then print out the equation of the quadratic and the line that we got. Print out the number of solutions that we got. How many solutions do you think? Don't forget to call your solve function and press run. There are 31 solutions